Hey guys, welcome back. We are talking about again saving your reels and building Trott. So let's get into the technical discussion and pick up right from where we left. Okay, let's come to the search part. The second functionality, what we are doing is search. Second or third, I guess, search. Let's come to search. So here, what we are doing is we are using Mongo to store data. The reason for using Mongo to store data is supports RAG indexing. Second, free tier. Third is familiarity. So I heard some of the SQL services like Supabase is allowing us to do RAG searching, but I didn't had an idea at that time, and I was pretty familiar with RAG indexing in Mongo, and it gives you one free index. So I had to make do somehow, but yeah, it worked out, and it also had free tier, which can scale up pretty well up to a level. So that's why we went for Mongo. So now for searching part, things that can be searched: places, video. Basically two things, but you have in places speciality, location name, video summary, description. So maybe creator name. So currently this is not supported, but we can put it later. Okay. So the issue is, if you will see, there are two basic broad categories and there are four subcategories that needs to be supported, but we only have one index. So what ideally should happen is all of them should get the index and maybe you get a combined result from that, but that will not work out because we only have one index due to Mongo limitation. So I could either go for a higher tier and do the appropriate thing, but I decided to go for a quick fix here. So what I tried was I tried combining all of them and then creating an index out of it. So I tried combined index. So if you are familiar with RAG, you would know that RAG requires some kind of encoder. So I am using an encoder that has about, I forgot the name, but I think it was mini LLM. I think it has some 365 character limit of encoding, and all this data combined index. If I try to create a combined index out of all this data, what happens is it gets truncated too much because I have two ways of combining this index and stay within limit of 365, right? One is truncate, second is average. So both of them are bad. Truncate loses you context, average also technically loses you context. I tried both of them. Average performed a bit better, but both of them couldn't pick out when I tried searching for nuanced stuff. So what I did was I combined them, then split them, created a new table called chunks, stored them there. That's what I did. But okay, cons of chunking. So cons of chunking is, first, duplicates. The summary and the description may have similar types of data, which may give you duplicate result. So I had to deduplicate the data, duplicate the search result. So that is what I had to do. Second is not as good still. So this is not basically a con of chunking, but basically a limitation of the encoding system that I was using. A friend of mine told me that Google Gemini also had an encoding system, and maybe it would have been better if I used that. But one of the reason I didn't want to use a larger or heavier encoding system was because of my previous experience with encoding system. So larger and heavier encoding system may need me to move from CPU based machine to a GPU based machine, which will be costly. And second, it may take more time to process, which will also increase my cost, because my cost is now, because it's a cloud run service on that runs on demand basis, it charges me according to the minutes, the seconds that is being run. So it will not only charge me more, but it will also take longer, which may frustrate the user. And the search will, and another thing is the search will also be slower if I don't move to an appropriately sized or power strong machine, because every search, whatever the user enters, will need to be encoded, then matched, the vector needs to be matched, right? So for that reason, I didn't move to a bigger encoding system as of now. But so not as good still. When I say not as good still, so mostly there are two issues that I see. One is not matching exact results. Two is loose matching. So what I mean by not matching exact result is, for example, there was a place called Paper Moon, right? And I tried searching for that, and it turns out because the vector is kind of ambiguous, it didn't. The first top result was not the one which said Paper Moon. That is bad, right? That should not happen. Perfect matches should be the ones at top. So what I did was I created a combined search mechanism. Go here first. Combined search regex plus vector prior. So I created a combined search mechanism that gives you top 10 results, where regex takes the priority. So anything the regex matches, you will come in the top 5 results, and the other 5 results will be reserved for the vector set, so that you can kind of have a compromise between both the systems. So that pretty much solves the issue of not matching exact result. But now the problem of loose matching is still there. So what I mean by loose matching is, you type something unrelated or maybe related, something fuzzy, where the vector search should shine, but it doesn't. Sometimes what happens is something that is not as closely related to your keywords also shows up, right? But it is also pretty limited. Most of the times that I've tested now, it works pretty good. So yeah, so both of these issues have been mitigated. Okay, let me just give you an example of the search. Right, let me just pull up my visor. So let's say for exact matches we can go Aurora. So we have the Aurora matches. Let's go Northern Light. So yeah, catches Iceland, party in Thailand. See, so these are all vector matches. Food in Thailand. Okay, let's go for cafe in Thailand. So yeah, let's go here. Do we have any cafe here? Yeah, we have a mention of cafe. So yeah, so it works pretty well, right? All the searches, and it is pretty fast. So that's it, guys, for this part. We will continue in the next part about the other details, the remaining section of the technical discussion.
Take care.